Where are we going to use spacer cable on wind farms and why? Well, number one, where topography or soil conditions are unfavorable for bare wire or underground systems. So if we're coming down off a mountain ridge, we've got rock, we've got granite, bare wire is difficult to put in underground drilling, blasting can be problematic. Number two, we're going to have reduced total costs. Number three, multiple circuits, all the collector circuits on one pole. And number four, for wind farms, the cause of outage at these wind facilities was conductor clashing. You go up on the top of the mountain to get the high wind. That high wind is also a danger to those phase conductors. Bare wire systems are prone to outages in wind conditions. So with covered conductors, phase conductors slapping into each other, no problem, not an issue. We don't have outages from conductor clashing. Right-of-way limitations. How much of a right-of-way do we need? How much do we want to trim? How much do we want to remove the trees for? We also have improved voltage regulations. If you bring those phase conductors closer together, you're going to cancel out your mutual inductance. We're going to have 15 to 20% less impedance, 15 to 20% better voltage support at the end of the feeder compared to bare wire systems. So lower cost feeders compared to bare wire, we're probably buying less aluminum, which amounts to a significant savings. Thirdly, we're going to have much better reliability, less outages, lower cost, more revenue from megawatt production. Lastly, spacer cable is environmentally friendly. We're going to avoid 80% of the tree trimming. We're going to minimize the foliage disruption. We're going to protect birds, ground animals. It's going to be APLIC compliant, which is important out west, and we're going to have a much smaller carbon footprint. And as we talk about these benefits, we'll take a look at a couple of facilities. Here's Green Mountain Power in Searsburg, Vermont. The strings, meaning the power lines from the individual turbines to the collector circuits, they're mostly underground here, but all the collector circuits bringing the power back are spacer cable. Here's another Iberdrola Avangrid, Eversource, New Hampshire. And this is what we call a ridgeline wind farm. And you can see here, we use the pole line around town to bring those. We have put an extension going up to the mountain, and basically all that power is coming back with 34.5 spacer cable circuits on the existing distribution poles. Here's a series of 4 projects done on the border of Canada and New York State, Chateauguay, Bliss, Malone, and Altona. Here's a relatively flat wind farm, 4 wind farms. We used 556 KC Mill. These are 1.5 megawatt GE turbines, so we put 7 to 11, 12 turbines on each collection circuit, and we had 3 circuits per pole. These were more of the early days of designing these wind farms with spacer cable. Most of the strings on these farms were underground cable. Some of the strings were also a spacer cable because they didn't want to disrupt what forest they had there. And here's a famous Mount Greylock in Mass. This is a MWEC Berkshire wind farm. Here's a city of Summerside in Prince Edward Island, and here's a wind farm they have, and we connect that with 336 KC Mill at 35 kV. So here's Sandy Ridge Wind Farm in Altona, PA, and this was really high up and really steep to get down. It would have been very difficult either with bare wire or underground cable. Here's a small one in Steel Winds in New York. A Groton Wind Farm, a very natural area, very pristine area. We were very concerned of disrupting the environment there, so that's why they use spacer cable. And again, Hoosac Wind Farm in Florida, Mass. We see why we're using spacer cable at wind farms. If they're flat, and you're going to use the collecting system with all the circuits on all collectors on one pole line, it's a good idea. Otherwise, if it's a ridge line, spacer cable will save you a lot of money and give you good reliability.